Good morning, everyone. I'm Dewey, and my Tech Talk topic for today is EV batteries, a cutting-edge technology challenge. Last week's Tech Talk covered the pros and cons of electric vehicles, plug-in hybrid electric vehicles, and hybrid electric vehicles. I was finishing out writing this Tech Talk when I came across a radio interview with Joanne Muller, transportation specialist at Axios.com, who was saying EV batteries are the new oil and the US is lagging behind Europe and China in the race to make them. She went on to say that the historic shift to electric vehicles will give the US a fresh chance to achieve energy independence, but it will require complex strategic moves that won't pay off for years. There wasn't sufficient time last week to explore the entire article, so I suggested that I might cover it this week. According to Joanne Muller, the big picture is that most of today's advanced batteries, both for powering cars as well as storing clean energy, are sourced in Asia. Demand for batteries will skyrocket in the coming decades, and if the U.S. wants to control its own energy destiny, it will need a secure and resilient supply chain for critical materials and other components needed to make these batteries. If we don't do this, if we don't as a country invest in our supply chain, it will go to the lowest cost country, which is China, says Michael O'Cronley, CEO of a battery recycling company. Joanne Muller goes on to note that though President Biden wants half of all vehicles sold in the U.S. to be electric by 2030, the U.S. has only about 5% of the manufacturing capacity needed to hit that target. At the same time, other countries are setting equally aggressive EV battery goals, thus driving up prices for lithium, nickel, and other essential materials for manufacture. In March, Biden invoked the Cold War era Defense Production Act to encourage domestic mining, processing, and recycling of critical materials such as, of course, lithium, nickel, cobalt, graphite, and manganese. Also, the U.S. government has given several foreign companies incentives to build up refining and manufacturing capacity here in the U.S. Meanwhile, some U.S. car makers are scrambling to build their own battery plants to guarantee supplies for upcoming electric vehicles. This is a direct government action into building a heavy industry from scratch, the stuff of presidents past, said Simon Moores, CEO of a London-based Benchmark Mineral Intelligence. There is still a gaping hole in America's efforts, said J.B. Straubel, a Tesla co-founder, who is now the CEO of the battery component company Redwood Materials. Redwood plans to invest more than $2 billion to start building anodes in the U.S. later this year and start building cathodes by 2024. Joanne Muller's article did not include an explanation of why anodes and cathodes are apparently important components in electric vehicle battery technology, so consequently, I decided to check into what part they play, and here's what I learned. Lithium-ion batteries comprise four main parts: one, the cathode, and two, the anode that store the lithium. Three, the electrolyte that carries lithium ions between the anode and cathode, and four, the separator, a thin plastic filter that physically separates the anode and cathode, only allowing ions to pass through. When they're discharging, lithium ions move from the carbon-based anode, that's the negative electrode, through the electrolyte, an organic compound consisting of lithium salts, to the cathode, again the positive electrode, which produces energy in the form of electricity to power the EV. When charging the battery, the process is simply reversed. As I studied this process, I came across an article by Pearl Liu at www.scmp.com, that's the South China Morning Post, that had a different perspective on EV batteries and why they sometimes may catch fire. Now, I knew that lithium batteries in phones and other small devices had a bad reputation for fires. I think Ron even had a fire in his. But are they also dangerous in electric vehicles? Well, Pearl Liu first makes two important points. The electrolyte used in today's lithium ion tends to be volatile and flammable at high temperatures. Two, a number of car makers, including Toyota, are researching the use of solid-state electrolytes instead of liquid electrolytes to solve the problem. And that's per Liu at the lower right. A lithium-ion battery's capacity and voltage is determined by the lithium-based metal used for its cathode. Again, that's the positive electrode, which releases electrons in the battery powering process, as you just heard. Electric vehicle battery types are usually named for their primary components. And there are currently three major types of lithium-ion batteries, and I believe she means manufactured in China, that are used to power today's electric vehicles. One, NCM, in which the cathode, in addition to lithium, is composed of nickel, cobalt, and manganese. Two, LFP, made up of lithium, iron, and phosphate. And three, NCA, consisting of nickel, cobalt, and aluminum. I also learned, but not from Pearl Liu, that General Motors is teaming with South Korea's LG Chem to provide high-tech EV batteries that use less cobalt, which makes cells 1/3 less expensive and also last longer, in fact, much longer, like up to maybe 600 miles. No mention was made, however, of fire safety, and I began to wonder how safe different types of electric vehicles are. I found an answer in the following story. Just last Friday, 3 days ago, May 13th, autoinsuranceez.com updated a previously published story titled Gas versus Electric Vehicles 2022 Findings. To find the rate of car fires by vehicle type, the authors collected the latest data on car fires from the National Transportation Safety Board and also calculated the rate of fires from sales data by the BTS, which is the Bureau of Transportation Statistics. Hybrid EVs, that's plug-in hybrid EVs and hybrid EVs that have both a gas engine and a battery pack, had 3,475 fires per 100,000 sales and scored the worst. Now, gasoline-only powered vehicles ranked second with 1,530 fires per 100,000 vehicles sold. And listen to this. Fully electric vehicles, EVs, scored the best with just 25.1 fires per 100,000 vehicles sold. Well, based on this data, fully electric vehicles like Tesla and Polestar and others don't catch fire nearly as much as claimed in the news. Though EVs are pricier, you're way less likely to burn or burn up in one. Well, that's my Tech Talk story for today, and I am sticking with it. Thanks for watching. Stay safe, and so long.